Welcome back to the FIBO Data Model training. This is Jürgen, and today Semantics for Data Architects is a deep dive into the structure of the ontology-derived enterprise data model. The FIBO is the authoritative standard of financial industry concepts, their definitions and relations. The Enterprise Data Management Council, the EDMC, is a global association of more than 200 financial institutions. And they teach data management best practices, and they develop and implement industry standards. EDMC members, in other words, banks and investment companies, developed the Financial Industry Business Ontology, the FIBO, as a business conceptual model. And it has more than 2,400 classes that detail financial instruments, business entities, and processes as of release 2025 Q4. Now, because it is a business conceptual model, the FIBO conceptualization and relations are fully applicable for lower semantic taxonomies, concept maps, object, and data model. And one of these is the FIB-DM, which is a perfect conceptual data model. There's a chasm between semantic and conventional data management. FIBO is comprehensive, with detailed coverage of business entities, loans, securities, derivatives, and indicators. However, the EDM Council specified the FIBO in ontology web language OWL. Large financial institutions started implementations on specialized databases, RDF triple stores. OWL needs specialized ontologists, and IT departments must still support and design conventional databases. And as I found out when I first looked at the FIBO 7 years ago, it is difficult for even senior data modelers to leverage the industry standard for relational database management system design. FIB-DM is the bridge across the chasm. The FIBO in Power Designer, Irwin, and other tools. The industry standard becomes available in your data modeling tool. Yeah, so you work at a financial institution that already embraces model-driven development, industry standards, and reference models. And mainly this class is for data architects, data modelers, with experience in enterprise reference models. And you may have used FIBO design patterns and definitions. It's also for ontologists. No? If you have an in-depth understanding of the FIBO and you already use the reference ontology for your design, it's a way for you to spread adaptation across the enterprise. And finally, finance users, business stakeholders, subject matter experts with a working knowledge of entity relationship and ontology diagrams. This class is a deep dive for all data architects. And it's also a path for you to use the FIB-DM and build up semantic skills, build up ontology knowledge. FIB-DM releases as a Power Designer conceptual data model, CDM. However, other data modeling tools can import the native model file. And in particular, Irwin does a great job importing. It's straightforward and it completely takes in the Power Designer model without any loss of structure or documentation. Now, the class is also for both enterprise data architects who look at FIB-DM top-down and project data modelers who would more have a middle-out approach, exploring individual model packages. And there is also a class here, Semantics for project architects. And a word here, so throughout this deck, there are links And on the FIB-DM website, you can download a PDF of this PowerPoint, so you don't have to stop the video and write down links. No? So this deck is what I teach at licensed financial institutions. However, open source users can find the scope and name changes here. No, so there's a page about the open source version, and this year, House of Finance 15 Business Concepts. That list actually shows new OMG names and their previous FIBO names that are still in the open source version. And of course, on FIB-DM.com, you can download the FIB-DM Core model. Yeah, and this is what I mean about the path of becoming an ontologist. And for managers, I say your data architects already know the bank and finance industry, and they will make the best ontologists at your financial institutions. And the path means, well, in this year, understand the FIBO data model, then next year derive your project and enterprise models from FIB-DM, and as you do that, study and learn RDF-OWL. And with that, you will become an expert in both worlds, the semantic and conventional. And it's easy to master a new language and tooling if you already know the content and design. Yeah, here's a chart of the complete FIB-DM training course, and you should have completed the classes for managers and project architects. And now Semantics for finance users really is a deep dive into the 15 concepts. And I would say that's a prerequisite to understand this advanced class, Semantics for data architects. Now, and also you should have learned about the semantics for mid-size, large, and very large banks. Now, they're all flavors of the same thing, and it is worth to study all three decks. In particular, the very large banks explains the ontology to data model transformation. So it's kind of like a better understanding of what we are looking at today. And after this class, you should study the articles. In particular, Article 2, ontology versus data model hierarchy, and probably the most important one, object properties are associative entities, because they explain the semantic data model design patterns in detail. Yeah, about myself, I worked in finance for 20 years, and in particular, I was an IBM software group consultant for their data model, the banking and financial markets data warehouse. And in that capacity, I trained architects on the model and advised them on implementation in North America, Europe, and Asia. Yeah, and after that, I consulted Citi and Deutsche Bank on the IBM model implementation. And since its beginning 7 years ago, I was a speaker at FIBO conferences. And my company, JZ Data Model, is a US corporation and has been in business since 1999. And JZ holds the FIB-DM copyright and is the assignee of the Configurable Ontology to Data Model Transformation patent US 12038-939. Yeah, the EDMC and OMG have been collaborating very closely for several years now. EDM Council is in their own words, a member-driven trade association dedicated to data management and analytics. It was founded in 2005, and like I said before, they teach best practices, standards, and education to business professionals. And the OMG is a standards development organization. It's global, and I think there are over 200 large companies are members of them. It's non-profit, and they craft technology standards. Yeah, FIBO Council Object Management Group, global association of over 200 financial institutions, and you are probably a member of the EDMC. No, and they teach data management, and you have probably taken out that exercise, no, with the EDM Council, the data management capability assessment model. Well, and EDMC has developed the FIBO, and the object management group is well known, more than 220 member organizations, and we all know their standards, the unified modeling language, business process modeling language, and now 3 years ago they published the first version of the Commons ontology library. Well, and now the two have merged. The Enterprise Data Management Council acquired OMG effective October 1st, 2025. And the combined EDM Association is the world's largest non-profit trade organization and standard setting body for data management. FIBO and OMG Commons. The Financial Industry Business Ontology defines the set of things that are of interest in financial business, and also how these things relate to each other. And with that, the FIBO gives meaning to data in the organization. And that is the OKG, the ontology knowledge graph. No, and data in the organization can be spreadsheets, relational databases, XML documents, and so on. And here's a link to the FIBO page on the EDM Council website. Now, the OMG Commons library has a set of small related ontologies, and they provide useful generic modeling constructs, and they can be used in different modeling and data deployment environments. So OMG Commons is designed as a foundational or upper ontology. It is independent of the domain or industry. And the FIBO imports OMG Commons ontologies. And with that, the FIBO deprecated foundational classes in the FIBO business entities, business finance and commerce, and foundation modules.
Le roi est mort, vive le roi.
The vision is Semantic Enterprise Information Architecture, SEIA. Now, when we look at architecture, we can differentiate by the use. Is it for business, design, development? By the type of the artifact. Is it conceptual, logical, physical, or is it implementation? And we can look at the level where it applies. Is it enterprise-wide, departmental, or for individual projects? And today we already have conceptual and logical data models that we physicalize, and that we deploy on RDBMS. And you likely have XSD for messages, BPMN for processes, and you have UML for object models and generating code. Now, what is new is we have the FIBO in RDF OWL, and that deploys on RDF stores. And with FIB-DM, we have the FIBO as the conceptual data model. And we can also generate other models like UML out of the FIBO. And finally, there is FIB-CM, the concept maps, and they are a simplified diagram for business users that we keep in sync with the data model and ontology. Yeah, the way to SEAI is model-driven development. And we have relational databases and now also semantic triple stores or RDF stores. And we have the industry standard, the FIBO in RDF OWL, and we always had data models that deploy on RDBMS. And with CODT, the configurable ontology to data model transformation, we have the sibling of the FIBO, FIB-DM, as the conceptual data model. Yeah, how do we derive in semantic model-driven development? At the conceptual model, we have the FIBO as the domain ontology. We have FIB-DM as its conceptual data model. It's for the financial industry, for the bank or investment company, and applied at enterprise level. And then on the logical level, we scope models for data, message, process, and object from the ontology or from FIB-DM. Well, and finally, on the physical level, then we deploy the design on relational database and other architecture artifacts. Applications, messages, XML, and so on. So the ontology is at the apex of the architecture, and that ensures common names, definitions, and design across the enterprise. Yeah, CODT is the superior technology, and it's patented the configurable ontology to data model transformation. And Atlantic CODT is a version of it there where it really became production grade. No? And you can learn more about Atlantic version in Semantics for extra large banks. So it's configured for logical data model naming convention. It's scalable to transform very large ontologies like the FIBO. Now, if you remember, the FIBO has almost 2,500 classes, and the FIBO download on the EDM Council website, it has 250 RDF OWL files. And CODT can process very complex ontology constructs into entities and relationships. So it goes way beyond the simplistic approach of class to entity and object property to relationship. Also, CODT transforms the complete FIBO documentation. And you have it in your data modeling tool in Power Designer as extended attributes, and in Irwin as user-defined properties. Yeah, and here are the configuration settings for the latest FIB-DM version, and they determine how the model looks like. So we have information about the source ontology, which can be either be an ontology development platform like TopRate or Protege, or it can be an RDF triple store. Typically, we exclude the all thing and all nothing, so that doesn't generate an entity. We have a target model, and in that case, that's only Power Designer, because Power Designer has a very sophisticated import functionality for MS Excel spreadsheets. We can specify the type. In our case, FIB-DM releases as a conceptual data model, give it a name, a destination path, transformation rules. Here we infer packages. In other words, FIBO OMG ontologies become packages in the Power Designer model and subject areas in Irvine. We do not transform anonymous classes. Anonymous classes are defined classes that do not get instantiated, loaded with triples on the ontology platform. And a defined class, a named defined class, becomes a separate entity. And this is important for, in some cases, we have an alias in the FIBO, no? So the equivalent class means that an instance of class A is also an instance of class B. And in FIB-DM, that becomes a separate entity that is marked as a defined class. Object properties become associative entities, not relationships, when data properties are attributes. And then for the names, we can say like where the code comes from, that's a qualified name. And the name is basically an uncamel of the local name. And there are some more rules to configure how to deal with duplicate names. And and finally, the Power Designer comment property in Irvine, that's a definition. We derive it here from the SCOS definition or RDFS comment on the ontology class. Data modeling tool imports struggle. For example, some would create entity names from URIs, which doesn't help the data modeler, would create classes from data type properties. Some imports would take class restrictions and create anonymous pseudo entities from them. A data modeling tool can parse individual RDF-OWL files, but with 250 FIBO files, a very large data model, it simply causes the import to crash. And complex semantics in OMG and the FIBO require configuration and also a holistic view of the source ontology. So holistic means we must look at all 2,500 FIBO classes. We must look at all 700 FIBO object properties. And an example here is how you treat inverse object properties. So the simple transformation that tools do is object property to relationship. So here we see like a loan has a principal amount, the CD has a notional, and the fund has a monetary amount. However, in the FIBO, these object properties are a hierarchy. The principal is a sub-property of the notional amount. So the correct way to transform this is in associative entities and with our data modeling subtype to model the hierarchy. And another issue is inverse object properties. No, that's where you have the opposite object properties. So in the FIBO you may find manages and is managed by. However, in a data model, we do not draw two lines between the entities. No, that would be wrong. But in order to identify inverse object properties and to resolve them, first we must have that holistic view of all object properties. And second, we need configuration rules that tell how we deal with inverse object properties. No? And the configuration in CODT is simple, that we would use the active form of the object property. Also, sometimes we may have to resolve duplicate names, so we need a configuration rule that helps us to create a unique name. In CODT, typically that is adding the source ontology code to the entity name. Yeah, and then there are complex class restrictions. Now, some values of all values from unions, and here it is important that an ontology-derived data model contains all associations, not simply domain and range, no? And the CODT is the only transformation that fully harvests all relations in the FIBO. Yeah, so the Financial Industry Business Data Model, FIB-DM, the FIBO in Power Designer and other modeling tools. It has 3,173 entities as of the latest version, Q4 2025. Complete definitions, annotations, and axioms, the business rules. Data architects can leverage the full content of the industry standard. We achieve a common language and design patterns for semantic and relational databases. So some of our principles and considerations for the derived data model must be practical. And it must be complete. We don't want to miss any information or metadata from the source ontology. It has to have complete documentation and diagrams that depict subject areas and design patterns. And finally, the model maps back to its source, the ontology. Yeah, so how does CODT work from the FIBO to FIB-DM? The configurable ontology to data model transformation is basic ETL. On the left-hand side, we have the OWL. On the right-hand side, we have Power Designer, the data modeling tool. We extract, transform, and load. We extract metadata from the source ontology, transform ontology metadata into conceptual model metadata, and load it into Power Designer. The extraction process runs SPARQL on the ontology platform to retrieve metadata. Power Designer imports MS Excel workbooks. And then the transformation becomes a simple two-step process. using the patented metadata sets. Yeah, so this is a two-step process with the CODT metadata sets. An extract process populates the ontology metadata set for classes, object, data properties, and annotations. And step 1 transforms metadata and populates a generic entity relationship representation. And the tool-specific metadata set is in Power Designer format. So we create an MS Excel that we can directly import into Power Designer. So then step 2 is a simple conversion from generic entity relationship to Power Designer objects, properties, and extended attributes. And one note here, now Power Designer has a very sophisticated import for Excel spreadsheets that can create entities, relationships, and so on. And Irvin doesn't have that functionality. So if you want to create an Irvin tool-specific metadata set, you have to code API. And that is the reason why FIB-DM's master file is Power Designer. And while even for COD licenses, I don't recommend coding a direct Irvin import, simply because it can easily import a Power Designer file. So that means the easiest way is to take one Power Designer license and then import into Irvin. Yeah, so here again, transformation settings for industry domain ontologies like the FIBO. So the COD patent US 120.38939 configurable ontology to data model transformation enables the ontologist and data architect to control the process and mapping, and to create a practical, usable enterprise data model. We said anonymous classes do not transform into entities. And instead, FIB-DM harvests all entity associations that are stipulated in a defined class. And the full class restriction is preserved in the entity documentation. Now, names transform from owl camel case to logical data model English names. Now, so basically capitalize the first letter and insert a space. Now, so here the FIBO, Finance Business Commons, a depository institution becomes depository space institution. Object properties transform to associative entities, not simple relationships. And that preserves the semantically important object property hierarchy, and it resolves open world properties. Domain range and class restrictions determine the parent and child entities related to the associative entities. In other words, they determine the relationships in the FIBO data model. The ontology-derived data model. On the left-hand side, we have an ontology graph from the FIBO. We see here it shows a bank account identifier, which identifies a bank account, and the bank account is provided by a bank, which is a subclass of a depository institution. And on the right-hand side, we see the derived conceptual data model. And here we see classes transform into entities. The subclass in the ontology transforms into data model inheritance or subtype. And object properties transform into associative entities, not relationships. And finally, the relationships between base entities and associative entities, here the cardinalities, they derive from class restrictions, domain, and range. And this mapping diagram actually is figure 1 of the CODT patent drawings. Yeah, and the domain ontology generates a perfect conceptual data model. So this entity relationship diagram is the best representation of the bank account, its provider and ID that a senior data architect would come up with. There are no missing entities, no unnecessary entities or relationships in the design. Ontology and data model are the same, 100% in sync. So here we see a FIBO ontology graph, a stock corporation with a class restriction that it has to have issued capital that must be one monetary amount. And also the monetary amount has a child of balance. Furthermore, the stock corporation is a corporation which is a legal entity, and the legal entity has a street address, which is a physical address and has some country. And the generated data model shows the stock corporation, subtype of corporation, subtype of the legal entity. Stock corporation has an associative entity, has issued capital, pointing to the monetary amount, and its subtype the balance. The legal entity has a legal address, the street address, subtype of physical address, which has a country. So beyond our object property range and domain, the ontology transformation infers data model relationships from class restrictions. Here, the OMG Commons legal entity, which has a class restriction, and that drives associative entities and relationships in the data model. And that is what makes CODT superior to other transformation attempts. Here, the open source version is a 1000 entity model derived from FIBO 2018 Q4. It has more than 1000 entities, not comprising of FIBO Foundation, Finance, Business and Commerce, and business entities. And here the chart shows the full commercial version with, as of 2025 Q4, 3,173 entities. And we can see the major changes were the addition, the import of OMG Commons, which replaced entities in FIBO Foundation and Finance, Business and Commerce. We see the new loans package with over 100 entities But there's far more in the FIBO than just loans. And that is because anything that is shared between loans and fixed income securities, like the guarantee, as we will later see, has moved to FIBO, Finance, Business and Commerce. So both loans and securities import the same upper level constructs. A huge package in the FIBO has always been derivatives. Indicators include market indicators as well as economic indicators. We have corporate actions. And then here we see scores and semantic metadata. That doesn't generate many entities. It's mainly for annotation properties transformed to data model documentation items. And we have OMG languages, codes, and countries. That is also present in the open source version. And here the direction OMG is taking is that more and more OMG LCC content gets incorporated into Commons. FIB-DM open source is a self-contained standalone quality data model. So we can look here at the level of detail, the upmost level generic, that's where the ultimate supertype in the data model are. We have a domain core, we have domain detail. So generic packages are OMG Commons, and in the open source here, the white area, OMG LCC, scores, and specification metadata. And then we have the domain core, FIBO Foundation, and its specializations, Finance, Business and Commerce, and FIBO business entities. And then for the commercial license, shaded in green, we have domain detail, FIBO loans, securities, corporate actions, derivatives, indicators, market data, and collective investment vehicles, in other words, funds. The key to the industry standard is a two-pronged learning approach. So enterprise architecture focuses on the hierarchy, the 15 fundamental concepts and associative entities. Whereas solution architecture, project modelers, application architects focus on FIB-DM packages, the FIBO modules for the project, not for the whole model. So here, for example, they may pick FIBO loans and mortgages rather than rationalizing the whole 3,000 entities top down. Yeah, and we learned the 15 fundamental business concepts in Semantics for finance users. And here is a picture of all of them, the 15 major concepts and the minor concepts at the bottom. And it kind of resembles a house. So all 15 concepts are extensive ultimate supertypes in FIB-DM. In other words, they have the most subtypes and the most relationships. In the ontology, the fundamental 15 concepts are direct subclasses of the thing. And we use abbreviations and icons to teach the concepts to modelers and business users. In other words, you use the icons, the conformed names and arrows to communicate your design with the user rather than a complicated ER diagram or ontology graph. Yeah, so 15 concepts, all with a name, an icon, and an abbreviation. And let's do a 10-second each rundown. Situation, contracts, agreements. The agent is what a concept is, the person or a legal entity. The role is what it does. As an employee, borrower, lender, regulator, and so on. Designation mainly used for IDs. Constituent details contracts. Collections are groupings or lists of things. Aspects are dimensions on other concepts. Specifications can be technical documents or expressions and formulas. Arrangements mainly used for codes and code sets. Measures is what we observe in the real world. Economic measures, market measures, and so on. Occurrence is events, including directions. The temporal entity has dates and times. Documents are documents. Scalar quantities can be currency amounts, numbers, in other words, quantities or percentages. And of course, we want to have the account. So all FIBO concepts are ultimate supertypes in the data model. And here the table and chart just shows the number of subtypes under the ultimate supertype. And we see the biggest one is situation, followed by role, designation, constituent, the agent, and so on. The concept map corresponds one-to-one to the data model. So here's an example of a concept maps for regulatory report to the FDIC, the US Federal Deposit Insurance Corporation. So we see here our bank is a depository institution, and it's identified by an FDIC certificate number, the license to do banking. And that ID is registered in the FDIC registry, and the authority here, the FDIC, its role as a regulator, registers the ID. Furthermore, the depository institution is a stock corporation. It has a legal entity identifier. It has issued capital, and it has a physical address. And this corresponds directly to the data model. In other words, you can leverage the 15 concept and design a concept map with your business user or subject matter expert. Then, as you go back to your workplace, you can directly scope concept map symbols to entities in the data model. arrows are associative entities. And with that, you can scope a subset model from FIB-DM. So for about the 15 concepts and concept maps, revisit Semantics for finance users. And about scoping from FIB-DM, this year I'll explain in greater detail in the next lesson, scoping a data model from FIB-DM. So this concludes the first part of Semantics for Data Architects, and the second part, which looks at the data model structure for entities, relationship, associative entities, and design considerations for derived logical models, is in a separate video. Okay, thanks for attending this class, and watch the next lesson.